Hi, welcome to my video on the type and number of equal and unequal roots, part 2. D is the value of the discriminant of ax squared plus bx plus c equals 0, where a is not 0. So let's complete the table. Before we complete the table, we have, in relation to D, the discriminant, if D is greater than 0, then the roots are going to be real and they're going to be unequal. And if D is equal to 0, then the roots are going to be real but equal. And notice equal 0, equal roots. If D is less than 0, then the roots are going to be imaginary and unequal. So that was from the previous video. Now we're going to just reinforce and practice this again. Notice D is the value of the discriminant. So if the value of the discriminant is a -8, that means D must be less than 0. And if D is less than 0, the roots must be imaginary. I'm going to put, I just spell it out, okay. And they must be imaginary and they must be unequal. That's like root 3i and a -3i, or 1 plus 2i, 1 minus 2i. The value of the discriminant is 9, then that means that D is greater than 0, 9 is greater than 0, so the roots are real and the roots are unequal. And if D is 0, then D is equal to 0, and that means we have real roots and equal to 0, the roots are equal. And if D is 12, D is greater than 0, 12 is greater than 0, so greater than 0, the roots are real and unequal. So I keep practicing that to make sure I know that will come in handy later and in future math, so learn it now and you'll have less trouble later. Which value of discriminant fits the roots of ax squared plus bx plus c equals 0, where a is not 0? So if we have the roots that are real, then real can have a discriminant that's greater than 0, equal to 0, but not less than. But it can also be greater than equal to, and none doesn't fit. Imaginary. If you have imaginary roots, then that means that D must be less than 0. If you have equal roots, you can only have D equals 0. If you have unequal roots, then D can be greater than 0, D can be less than 0, and it's a little bit in here. We can have greater than 0 but not equal to, so it can't be this one. Or we could take that, I suppose, because it does obey one or the other, but it doesn't obey equal to. Real equal roots must be D is equal to 0. Real unequal roots, D is greater than 0, and that's it. Because right here, D is equal to 0, not unequal. Unequal when D is greater. Equal to 0 when real and equal. Imaginary equal roots. If you have imaginary roots, you can't be imaginary roots. Well, they can't be. D is greater, because imaginary roots is D is less than 0, but when you have imaginary roots, you have it unequal. So there's no such thing as imaginary equal roots. The imaginary roots has to be unequal, so there's none. No values. Imaginary unequal would be D is less than 0. So just a review to make sure you know what you're doing. Let's move on to what we call conjugate pairs. Because anytime you have real roots and you have root 2, then its conjugate is a negative root 2. They're conjugate pairs, negative of. If you have a negative root 11, the conjugate is positive root 11. The conjugate of 4 plus root 7 is 4 minus root 7. The conjugate of 3 minus or 6 minus root 3 is 6 plus root 3. Notice in the binomial you're changing the second one. A plus to a minus to a plus, but you don't change the first one. Because if you change the two of these, you're doing opposites, but we're only doing conjugates. In other words, with conjugates, when you multiply root 2 by negative root 2, you're going to get a real number. When you multiply 4 plus root 7 by 4 minus root 7, you're going to get a real number. And when you multiply conjugates here, when I say real number, but not only are they going to be real, they're going to be rational. They're not going to be irrational. Root 2 is irrational, so its conjugate is a negative root 2. So the conjugate product is a rational number. Negative 8 minus 2 root 5. So when you multiply, you will get, these are irrational numbers. When you multiply these two conjugates, you'll get a rational number. Negative 1 plus root 10. Again, irrational numbers, conjugates will give you rational. What about imaginary roots? So if you have a 3i, then the conjugate is a negative 3i. So when you multiply, notice I changed the sign. When you multiply, the product will become negative 9i squared, which is negative 9 times negative 1, which is 9. So when you multiply it by imaginary number by its conjugate, you will get a real number. So it's a 4i. Change the sign. Change the sign of the second one, 1 minus 5i. Again, the product of these two imaginary numbers will be a real number. The i's will go because you'll get an I squared. 7 plus I is its conjugate. Negative 2 minus 6i is its conjugate. And negative 9 plus 11i. Again, in conjugates, I change the sign. Plus to a minus to a plus. When you got a binomial, you change the second one, not the first. Most teachers will change the second. You change the second one, not the first. Change the second one. Notice the negative 2 and the negative 9, the 7 and the 1 stays as is, whatever the sign is. It's the second one that you change. C, ax squared plus bx plus c equals 0. A is not 0. And A, B, and C belong to the rational numbers. Q means rational numbers. State the other roots of each. So we're going to have rational numbers for the roots. So if D is greater than 0, if you got a root of 6, then you can have any other real number. But you cannot have 0. 0 is not going to work. So there's any other number. Remember, we can't say real number, any other rational number. So it has to be a rational number. It can't be irrational. It has to be any other rational number, but not 6. Because greater than 0, the roots are going to be real and not equal. So it can't be 6, because if the other root was 6, then they'd be equal, and that will give you D is equal to 0. So any other rational number, not a real number. If you have D is greater than 0, then the conjugate is 3 plus root 7 is the other root, because they're in conjugate pairs. If D is equal to 0, that means the roots are equal, so you got to have a negative 4 for the other root. And D is less than 0, which means you have imaginary numbers, and imaginary numbers, the conjugate is 1 minus 2i. So when you have irrational like this, the conjugate. When you have imaginaries, the conjugate. And right here, you could have any rational number. You could have, if you got 6, you could have a 2, you could have a negative 3, you could have 1/2, you could have a negative 7/8, any other number, but not 6. And you can't have it irrational for this one. You can't have an imaginary number for this one. Just reviewing what we learned. All quadratic equations, ax squared plus bx plus c equals 0, where a is not 0, have a degree of 2. Notice the degree of 2. The highest degree is 2. Hence it has 2 roots. So what I'm going to do now is explain what about x squared plus 6x plus 9 equals 0 when you solve for x. So we can solve this quadratic by factoring, completing the square quadratic formula. But I want to do each of these to show you something. Let's solve this by factoring. So if we solve by factoring, we have a 1x squared, so we have an x and an x. The factors, the product is 9, the sum is 6, so the product is 9, the sum is 6, it's got to be 3 and 3. Since the product is positive and the sum is positive, it's got to be plus 3 plus 3. So that means that you have x plus 3 is equal to 0, or x plus 3, you have two of them. So you get x is negative 3, and x is negative 3. So you see that I have a quadratic, I have two roots, and the two roots are equal. Okay, let's solve by completing the square. So x squared plus 6x plus 9 equals 0. So complete the square means you move the 9 to the right side and make it negative. So what we're going to do now, to complete the square, we go 6 divided by 2 squared. That's 6 divided by 2 squared is 3 squared, which is 9. So to complete the square, I need to put a 9 there, but I also put a 9 here to balance it. That means the factorization of this is, see, right here you got x plus 3 times x plus 3. That's the same as x plus 3 squared. But when you're completing the square, yes, you can write this down, but the shortcut is a half of this 6 is a 3, and the 3 plus 3 is what goes inside here when you square. And the right side becomes 0. So that means you do the square root of x plus 3 squared equals plus or minus the square root of 0. That means that you're doing, let's go up here, you're doing x plus 3, square root of x plus 3 squared is x plus 3 equals plus or minus 0. Oop, that's a 0, I put a 10 there, not being cute, just be careful, that's a 0, square root of 0 is 0. So that means x equals negative 3 plus or minus 0. Now, if you were to add these right now, negative 3 plus 0 is negative 3. Negative 3 minus 0 is negative 3. So if you said that x is 3, negative 3 right now, you'd be okay. But think about it. If you did negative 3 plus 0 or negative 3 minus 0, x would be negative 3 or negative 3. So if you did the plus minus with the 0, you get the two roots. But if you only went with x equals, adding and subtracting 0 gives you that, you would only say there would be one root. But yes, the roots are equal. They're the same. As you can see, the two of them are the same. So be careful when you're solving this. Yes, you have a root of a negative 3, but there's two of them in this case. Note, you can do it this way to get the two of them. You can factor to get the two of them, but there is a root of negative 3, but there's two of them, and that's important when we do it later on. And every quadratic has two roots, but in this case, we only get a negative 3, but there's two of them. What about if we solve it by quadratic formula? Well, let's see. Quadratic formula, A is 1, B is 6, C is 9. So x equals negative b plus or minus b squared minus 4ac all over 2a. So b is 6. We'll put a1 there. B is 6, c is 9. So that's the negative of the 6 plus or minus 6 squared minus 4 times 1 times 9. 2 times 1. Again, a is 1, c is 9. So that gives me negative 6 plus or minus. And if I work this out right here, let's do it up here. 6 squared is 36. Negative 4 times 1 times 9 is a negative 36. That gives me a 0. So you notice that 0 is the discriminant. So that means we got a negative 6 plus or minus 0. If the discriminant is 0, we've learned that what? We have two equal roots, and they're real. Well, we can add these, so that's negative 6 when you add on 0, or negative 6 minus 0 is negative 6 over 2. So that's negative 3 or negative 3. But again, most students working this would say Negative 6 plus or minus 0 is just a negative 6. So we get a negative 3. They would just get the one root. But remember, there are two of them. There's negative 6 plus 0 and negative 6 minus 0. So there's two roots. But if you only got one of them, you have to remember that there is another one called also negative 3. And that's why I'm solving it by different methods to show you that there is two of them. Notice the factoring says there is two of them because they're equal. So that brings us to the end of finding the types of roots and the number of roots. Oops, sheet shouldn't be there. If you like my video, click the like button, click the subscribe button, click the notification bell, and visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.